Hey everyone, welcome back, and let's write some more neat code today. So today let's solve product of array except itself. So this is another problem from the blind 75 list. As you can see, it's over here, product of array except self. So I'm going to be adding that video solution today. And we're getting one step closer to having every problem in this entire list filled out. So for this problem, we're given an input array of integers nums, and we want to return an output array for every single number that we're given, where for each value in the input array nums, we're basically multiplying every single number except that value and then returning that as the result. For example, in this example, you can see we're given 1, 2, 3, 4. So for example, for this value 1, we would want to return the multiplication, the product of every other value. So for these three values, the product would be 2 times 3 times 4. That's going to be 24. So for the first value in the output, we're going to put 24. Similarly, for the second value, we want to multiply every value in nums except for this value. So that's going to be 1 times 3 times 4. That's going to be 12. So the second value in the output array is going to be 12. Now, the hard part about this problem is basically the restrictions that they give us. So we have to solve this problem in big O of n time, and we have to do it without using the division operator. It would be really easy if we could use the division operator, because what we could basically do is take the product of all of these values, and we know that would basically be 24. So if we wanted the first value, so if we wanted 24, we would take this total product and divide it by 1, right? That would give us 24. If we wanted what the second value would be, we would take the entire product, 24, which would be all of this, and then divide it by 2, which would give us 12, which would be over here, right? Because the division is basically taking the entire product of the entire thing without multiplying by this. Dividing this would do exactly that. But we are not allowed to use the division operator. So if we wanted the product of every value in here except the 3, one way we can break it down is basically get the product of every value before 3 in the input array and get the product of every value after 3 in the array, and then multiply these two values together, and then that's going to give us the value that we would want to put in this position in our result. So it would be helpful for us if we want to do that for every single value in the input array, if we basically just compute the prefix product for every single position in the input array, right? And then put it in a prefix array. And since we're also going to be wanting the product of values after, it would also be helpful if we computed the postfix product of every single position in the entire input array, right? And we can compute both of these in big O of n time. It's a pretty simple algorithm, right? We'd basically start at the first position. Okay, this is going to be 1. So if we're adding this value, we're just going to take the previous value and multiply it by 2. So this is going to be 2. Similarly, we're going to take 2, multiply it by 3. We're going to get 6 here. 4, multiply it by 6. We're going to get 24 here. And for postfix, we're basically going to do the exact same thing and do it in reverse order. So here we would get 4, here we would get 3 times 4, here we would get 2 times 12, and then here we'd just get 1 times 24, which is just going to still be 24. Now for every single values, for example, 1, we would want the prefix of every value before it. Now, since there are no values before it, we can just say, okay, the prefix for that is just going to be a default value of 1 to keep it neutral. And so we'd also want the postfix of every value that comes after it. We can get that in the position to the right of 1. So we'd want to multiply those together. So 1 times 24. So in the output for this, we would get 24. That makes sense because if you multiply all these together, except for this one, we do get 24. And then we just repeat the exact same process for every value. So over here, we'd want the prefix of the values that come before it, and we'd want the postfix of the values that come after it. So 1 times 12 is just going to be 12. That's going to be the output. Again, repeat the same thing for here. The prefix is 2, postfix is 4. We're going to get 8 as the output. That makes sense. If you take 24, if you take every value in here, multiply it except for 3, we do get 8. And similarly for this 4, we'd want the prefix 6, and the postfix, there are no, so we just assume that there's a 1 over here. So 6 times 1, this would be the output. So this is a very valid solution. This is a big O of n times solution. We're not using any division operator, but the downside is this is also big O of n memory, but we can actually use this idea because what they tell us is the output array does not count as extra memory, so we actually don't need these prefix and postfix arrays, because we can compute these prefixes and postfixes and then store them in our output array, and that is going to end up making things easier for us because we're not going to have to use this extra postfix prefix memory. So what we're going to do is we're going to do 2 passes on our input array nums. First, we're going to start at the beginning and then go all the way to the end, basically computing every single prefix for the input array and then storing the prefix. So for example, the prefix of this is going to be stored over here, right? Because that prefix is needed to compute the result for this position. And so at that point, what we're going to say is every prefix is going to be in the output. Basically, the prefix over here is going to be stored in the second position. The prefix over here is going to be stored here. The prefix from this is going to be stored here. And remember how for the first position, there is no prefix, so we're going to put a default value of 1 over here. And then after that, we're going to do a pass going from the end to the beginning, computing every postfix. So for example, this postfix, and then in the result, we're already going to have the prefix stored over here. This prefix, right, the first 2 values is going to be stored over here. So what we're going to do is we're going to take this prefix and multiply it by whatever is in this position. That's what's going to give us the result that we want for this position. So let's start off. So far the prefix that we're going to be at is just going to be the default value of 1. So we're going to put a 1 over here. Then we're going to multiply it by what value comes over here. 1 times 1 is going to stay 1. So we're going to leave our prefix as it is. Now we're going to be at the second position. So what we're going to do is take our prefix, which it basically tells us the prefix up until this point. We're going to take that and then put it in the output. So 1 is going to be here. And then we're going to take the value that we just reached, multiply it by the prefix. So now the prefix is going to be a 2. So now we're going to be at the third position. So what we're going to do is take our prefix up until this point and go ahead and put it in the output. So 2 is going to be placed in the output. Then we're going to take the 3 and then multiply it by 2. That's going to give us a 6 for the prefix so far. So at this point, we're going to take our prefix, 6. It tells us the prefix up until this point. So we're going to take it, put it in the output. 6 is going to be put in the last position. Then we're going to multiply 4 by 6, which is going to give us 24. But that value 24 is not going to be put anywhere because clearly we have run out of room to put it. So we don't need to store it in the output. So now we've visited every single value from the beginning to the end, computing the prefixes and then putting them in the output array. So now we're going to start at the end and go to the beginning and do the exact same thing, except we're going to be doing postfixes, which are basically starting from the end of the input array and computing the products. Once again, the postfix is initially going to be set to 1. So what we're going to do is take the 1, which tells us the postfix up until this point, basically an empty thing. And that makes sense because for this value 4, we would want the prefix of it as well as the postfix, but there is no postfix, so that's just going to be a 1. So we can take that 1, multiply it by 6. So 6 is going to stay the same, so that's going to be the result value for this position. But then we're going to take 4 and multiply it by the 1 in our postfix. So our postfix is now going to be 4. So we visited this position. Now we're going to be at this second position. So we're going to take our postfix, which tells us the postfix up until this point, and then multiply it by the 2 that's in this position. So 4 times 2 is going to give us an 8 for the output value. Then we can take this value 3, multiply it by our 4, which is going to give us a 12. So now we visited this value. Now we're at the next value 2. So we're going to take our postfix up until this point, multiply it by the 1 that's here. But that value 24 is not going to be put anywhere because clearly we have run out of room to put it, so we don't need to store it in the output. So now we've visited every single value from the beginning to the end, computing the prefixes and then putting them in the. Once again, the postfix is initially going to fix, which tells us the postfix up until this point, and then multiply it by the 2 that's in this position. So 4 times 2 is going to give us an 8 for the output value. Then we can take this value 3, multiply it by our 4, which is going to give us a 12. So now we visited this value. Now we're at the next value 2. So we're going to take our postfix up until this point, multiply it by the 1 that's here. So this is now going to be a 12. And we can also take the 2 and multiply it by 12, which is going to give us 24, which tells us the postfix up until this point, which is going to be useful for us because we know that if we want to get the product for this position, we're going to need that postfix. So we can take that postfix 24, multiply it by the 1 that's over here. So this is just going to be a 24 now. And that's the entire result. So we basically did the exact same thing that we did with our prefix and postfix arrays, but in this case we did it without using the extra memory, and we ended up arriving at the exact same result. So it was linear time complexity, big O of 1 memory complexity. Now let's jump into the code. So the first thing we're going to do is create a result output array. So this technically does not count as extra memory in the context of this problem. I'm just going to give each position an initial value of 1, and we want this to be the length of the input array, so we can multiply it by the length of nums. So first we're going to be doing the prefixes. So I am going to initialize prefix as 1, and then we're going to go through every position in our input array. So for each position, we're going to be doing the prefix. I'm just going to give each position an initial value of 1, and we want this to be the length of the input array, so we can multiply it by the length of nums. So first we're going to be doing the prefixes. So I am going to initialize prefix as 1, and then we're going to go through every position in our input array. So for each position in our result output array, we're going to take that prefix and then just put it in that position I, right? And then after we've done that is when we're going to take the input array value, nums of I, and multiply it by whatever the prefix happens to be. So prefix is just going to be multiplied by this value. So that's how we're going to be computing the prefixes as we iterate through the input array nums. And we're going to be storing the prefixes in the result output array. After we've done that, we're going to do the exact same thing with the postfix array. Well, almost the exact same thing. So we're going to start at the end of the input array and then go up until the beginning, and that's how you can do this in Python. And so in this case, the result of I, we're not just going to be simply storing the postfix value because we know that would end up overwriting in the result whatever the prefix we stored was. What we're going to be doing with the postfix is we're going to be multiplying it by the value that's already in results because that's simply multiplying the prefix and the postfix together. Once we've done that, we know we do have to continuously update the postfix. So with postfix, we're just going to multiply it by whatever value happens to be in the input array nums. And once that is done, we're actually done with the entire problem. Then we can just return the output array result. So this is pretty much we're going to start at the end of the input array and then go up until the beginning, and that's how you can do this in Python. And so in this case, the result of we're not just going to be simply storing the postfix value because we know that would end up overwriting in the result whatever the prefix we stored was. What we're going to be doing with the postfix is we're going to be multiplying it by the value that's already in results because that's simply multiplying the prefix and the postfix together. Once we've done that, we know we do have to continuously update the postfix. So with postfix, we're just going to multiply whatever the prefix we stored was. What we're going to be doing with the postfix is we're going to be multiplying it by the value that's already in results because that's simply multiplying the prefix and the postfix together. Once we've done that, we know we do have to continuously update the postfix. So with postfix, we're just going to multiply it by whatever value happens to be in the input array nums. And once that is done, we're actually done with the entire problem. Then we can just return the output array result. So this is pretty much the most efficient start at the beginning. So far, the prefix nums of I, multiplying it by the value that's already in results, because that's simply multiplying the prefix and the postfix together. Once we've done that, we know we do have to continuously update the postfix. So with postfix, we're just going to multiply it by whatever value happens to be in the input array nums. And once that is done, we're actually done with the entire problem. Then we can just return